Let's solve that same problem of finding the worst rated movies, this time using Spark 2.0 style data frames. So let's dive in and dissect this script that we're going to run on our cluster as well, or cluster of one virtual machine at least. So, unlike last time, we're not going to import a Spark context. What we're going to do instead is import something called a Spark session. And this is a new thing in Spark 2.0 that encompasses both a Spark context and a SQL context. So the new paradigm, if you will, is that in Spark 2, you create a Spark session object and leave that session running through your script. And you can execute SQL queries on it and whatever you want. And when you're done, you stop it and it's over. So we're also going to import the row object here. That's going to let us create data frames of row objects and some SQL functions so we can do things like compute the average of the ratings as we go. Moving on, load movie name, same function as before. It's basically returning that Python dictionary that lets us map movie IDs to movie names when we produce our final output. And let's again skip ahead to the main body of our script here. So, unlike before where we built a Spark conf and a Spark context, we're going to build a Spark session this time because that's the Spark 2.0 way of doing things. So we're going to call Spark session.builder.appName to give it a name that's going to show up in our console. .get or create, and that will return a Spark session object that we're just going to call Spark. Now, get or create is worth talking about. One neat thing is that these Spark scripts can actually recover from themselves. So if you were to actually have some sort of a failure, get or create means I will either create a new Spark session, or if I didn't successfully stop from the last time, create from a saved snapshot of that session and pick up from where I left off. So kind of a neat little feature of Spark sessions. We'll create our movie ID to movie name dictionary for later, and then we'll dive into the meat of using Spark. So this time, we can see that our Spark session contains a Spark context, and we can still call text file and anything else we could do on Spark context with that, and we'll do it that way for now. So we'll use the same old text file interface to load up our u.data file that contains all of our movie ratings from HDFS into a new RDD called lines, okay? So same as before, just a little bit slightly different context here. And Spark Session also has some built-in ways for reading text files directly without going through a Spark context. But I don't want to get into too much depth. Now, just like before, we need to convert that into something else. And this time what we're going to do is create an RDD of row objects that we can later convert to a data frame. So all we really care about are the movie IDs and the ratings, right? So we're going to extract the movie IDs and ratings and create an RDD of rows that contain movie IDs and ratings. And to do that, we're going to use our parse input function, which is going to work a little bit different this time. So as before, we're going to split the input fields coming in from the u.data file one line at a time. And now we're going to extract the movie ID, cast it to an integer, and extract the rating and cast it to a floating point number like we did before. But this time, instead of just returning a tuple, we're going to return a row object that gives these fields names. So we have a row that contains a movie ID column or field that contains the movie ID and a rating field that contains the actual rating. So at this point, we have an RDD of row objects where each row contains a movie ID and a rating. And now we can call spark.createDataFrame to convert that RDD into a data frame. And it has all the information it needs built in about the types and column names to do that. So now that we have a data frame, we can do cool stuff with it. So for example, let's figure out the average rating for each movie. We can do that with one line of code here, whereas it took several steps before using RDDs. We can just say movie dataset.group by movie ID, and that basically does a reduction by movie ID. Collects all the ratings together for each unique movie. And then all we have to do is say .avg to average those ratings together into a final number. So what we end up with here is a new data set called average ratings that contains a movie ID column and an AVG rating column that contains the average of all the ratings for each movie ID. So you can see that's a lot easier to use than the previous RDD interface. Now, just to make things a little bit more interesting, you remember we got some kind of dodgy results when we did this with RDDs because we had a lot of one-star movies that were probably only rated by one person. Should those really count? Well, I don't know. But let's get a handle on how big of a problem that really is by also outputting the count of how many ratings exist for each movie. So now we can see side by side next to that 1.0 average rating how many people actually rated it 1 star to deserve that. So to do that, similarly to how we got the average rating, we can group the original movie dataset by movie ID again, and this time call count to get the count of how many ratings for each movie ID occurred. So now we have 2 datasets, one that contains movie IDs and average ratings, and another one that contains movie IDs and counts. And we can join those together into a single data set using join, just like you would in SQL. And what we're going to do is say we're going to take the counts data set and join it with the average ratings data set using the movie ID column to join them together. And then we can just pull out the top 10 results, and while we're at it, sort them by the average rating column that came out of our average ratings data set. And after calling take, what we get back is a Python list that we can then iterate through again, print out the movie names based on the movie IDs and the average ratings and count of a number of ratings as well. Stop the session and we're done. So you can see using datasets can be a little bit simpler, a little bit easier to follow from a coding standpoint. You have to think a little bit less, and it also gives you a lot more flexibility because, in addition to explicitly calling these functions like group by and order by, I could also just issue SQL commands if I wanted to, which is like super easy. And since this is more structured information, Spark can actually deal with it more efficiently. So you get all sorts of benefits by going in this direction. And these data frames that we end up with are interchangeable with other components of Spark like MLlib and Spark Streaming, which is also really cool. So with that, let's actually run this bad boy, shall we? So to do that, we'll again log into our cluster. I already have mine running, as you can see here. So I'm going to log back in as Maria Dev. And the password again is still Maria_dev. Now, I already downloaded everything we need to do this from the previous activity. So again, you should have the lowest rated movie DataFrame.py script. That's the one we're going to run right now. And if I do a lowest rated movie DataFrame.py, you can see that is the same script we were just looking at. And it too will depend on the ml-100k/u.item file to get that dictionary. So that should be in there. And we are also assuming that you already have the Movie Lens dataset installed on HDFS on this little pseudo cluster under user Maria_dev/ml-100k. So that's all the stuff this script expects. And if you ran the previous activity successfully, that should already be in place. Now, as of this recording, Hortonworks actually includes both Spark 1 and Spark 2 on its distribution. So you have to tell it explicitly if you want to use Spark 2. So to do that, we're going to set a little environment variable, just like this. Export, all caps, Spark_major_version equals 2. And that will tell Hortonworks that we want to use Spark 2 instead of Spark 1, and that will allow us to use things like the Spark session object. And now that we have that in place, we can just say, like before, Spark-submit lowest rated movie, if only I could type, rated movie DataFrame.py, and off it goes. We can ignore these errors. And since I'm doing a join, it did a little bit more work, but hey, there's our results. So top 10 results here. Not only can we see the average ratings of 1 star, but now we can also see the total counts. So we can see that, yeah, a further gesture only had a 1 star average rating, but only one person was behind that. So a single person rating it 1 star, not sure how much confidence I really place in that. However, Amityville Dollhouse had 3 people who rated it, and all 3 of them gave it 1 star. Probably means it's probably not the best movie. Same thing with Amityville: A New Generation. Well, I've heard of the Amityville Horror, but I never heard of Amityville: A New Generation, and I think there's a very good reason for that, because of the 5 people who actually watched it in this data set, all 5 gave it a 1 star rating, which is pretty terrible. Now, these results don't exactly match up with what we got before using RDDs, because we have so many tied results. The ordering was ambiguous, right? So that's okay. But when we get to our exercise later on, we'll make more sense of that. But there you have it. Same exercise using datasets and Spark 2 So exciting stuff. Again, this is the way of the future, and I hope it's a little bit demystified for you now. Up next, let's do something even fancier.